Let's discuss more about the OSC model. So if you see in this diagram, there is an application layer. In the application layer, we will represent our request as data. So whatever you are sending, like a hi message or you are sending username and password, so that will be the data. So in the fourth layer of the OSA model, so we will call our data, so whatever the hi or any username and password as a segments. So why we are calling as a segment? Because data will be splitted into multiple uh, parts. Okay, so let's see an example. So if there is a 30 MB of data, so it will be splitted into multiple chunks. Okay, so 5 MB, 5 MB, 5 whatever. Okay, so the data will be probably splitted into multiple segments. Okay, so that's why we are calling our data as a segments. Okay, in the transport layer, so we already discussed there is two protocol, only TCP and another one is UDP. So this will be either TCP will be added or UDP will be added. Okay, so after that we have a network layer. In the network layer we already know, so sorry for that. In the transport layer one more thing will be added, that was a port number of the protocol. If it's a HTTP, then the port number will be 80. If it's a HTTPS, then the port number will be 443. If it's FTP, then the port number will be 21. We will discuss the protocols and port number briefly in upcoming videos later on. So in the network layer, we will call our the segments as a packets. Okay, so that was a data packets. So we already know in the network layer the source IP address and the destination IP address will be added. Your data will be like this. Okay, transport header like TCP and the source IP, destination IP, and the data. We will call this entire thing as a packets. Okay, so let's take a look here. In the network layer, the source IP, destination IP, this will be added in each of the segments. Okay, each of the segments, the source IP and destination IP will be added. The data need to be splitted. Why we need to split the data? Because as per the internet speed, if the internet speed was 5 mbps per second, we need to segment this data into chunks, right? Into one by we need to divide this data into multiple chunks, right? Multiple segments. So we are segmenting the data and we are adding source IP and the destination IP in each of the segments. Okay, each of the segment that we segmented by the transport layer. Okay, source and destination IP will be added, right? So once we added the IP address in the network layer, then our packets will be come up to the data link layer. In the data link layer, we know the frame. Okay, sorry, we know the MAC address will be added, source MAC and the destination MAC, right? So for here now we have a one more thing, and the source MAC and the destination MAC address will be added in each of the segments like before. Okay, so finally our data will be reaching to the physical layer and our data will be converted to zeros and ones, right? Because our data need to communicate through the cable, right? It's RJ45 or any fiber optics cable. It's need to be transferred to the cable. So we are transforming our data into the bits. Okay, so we will call it as frames. So once you add the MAC address, our data packets will be called as a frames, and once it reaches to the physical layer, this will be called as bits. Okay, so this will be in the protocol data units. Okay, PDUs, we will say it as a PDUs. Okay, data segments, packet, frames, and bits. Okay, so I'll discuss one more time. whenever the data will be reached to the transport layer, we will call our data as a segments, because it will be segmented into multiple chunks, multiple segments. So once the data reaches to the network layer, we will be call our data as a packets, one packet, packet 1, packet 2, packet 3. And once the data reaches to the data link layer, we will call our packets as a frames, right? So once it reaches to the physical layer, so this data needs to be transferred to zeros and ones. We already discussed it need to be transferred to the cable, right? From one place to one source to one destination. So we are transforming our data to bits. Okay, this is the entire process of protocol data unit. Okay, so let's hop off this video and we will discuss the TCP and UDP briefly in the next video. Thank you for watching. To another video. So in this video, we will discuss about the TCP and UDP briefly. So there is a difference between TCP and UDP. So we all know that TCP will be added in the TCP and UDP will be added in the transport layer. It's a protocol. So we need the difference between both of this protocol. What are the features of the protocols? So why we are using TCP in many places, and why we are using UDPs in video streaming applications. So let's start with our discussion. So if you see, let's see the TCP first. So we will say the TCP is a connection oriented protocol. Okay, in the first point, it's a connection oriented protocol. So it means like the sender, you and the server will be connected each other till the completion of the process. Okay, so if you are communicating with the server, till the communication you both are connected, your connection will be maintained. Okay, so we are saying it's a connection oriented protocol. So apart from that, the TCP is used in the applications, like if you are sending some hi message to one of your friend in WhatsApp, the packet will not be missed, right? So if you are sending a big paragraph, the packet will not be missed, and we will give assurance to that packet it will be reached to your destination, your target server, right? So it's like a safe courier. So whatever you are sending as a assurance, it will be received to the destination properly without any missing of packets, without any missing of these characters. Okay, there's not only a character. So if you are sending some usernames and password, so this both will be shared to the server, right? So if any one of the in password, any one of the character will be missed, then the website send an error like there is a mistake in username and password. So we are using TCP there. Okay, so the TCP will give assurance to your packets. It will be received uh, to the receiver. All the packets will be received to the receiver. Okay, in TCP. But if you see in UDP, it's a very fastest service, very fastest protocol. Okay, the TCP is bit slow. It's very slow compared to UDP. So UDP we are using in video streaming applications like IMO video calls and YouTube streaming and some video call applications like Zoom or anything. Okay, so in here, if your internet connection has an issue or your network speed has reduced, some packets will be missed, right? So this needs to in UDP. So there is a two things: audio and videos will be shared accordingly, right? So you may faced some issues there. So sometime in IMO, your audio will be uh, given to you after some minutes of the video, or else the video will be present to you after some minutes of audio, right? So there are some issue in UDP. Okay, there is, we can't give assurance every packets will be received to the receiver. So UDP has a drawback for that. Okay, so UDP is very fast, so we are using the UDP in most of the video streaming applications. And because in video streaming application, the videos and audio needs to be transferred to the receiver continuously with the audio and video, so the protocol needs to be very faster, so we are not using TCP here. Okay, so now let's discuss how TCP is sharing the packets without any of the interference. Okay, basically TCP have a three-way handshakes. Okay, so SYNAC and DAC. It's like hi there. So this receiver will send a hi. Okay, hi, I am here. Okay, I will send some packets to you. So this is like hi, hi, I am live. I'm going to send some packets to you. That is an acknowledgement. Okay, sing is a hi, SYNAC is a I am here, hi, I am here, and ACK is a I'm going to send some packets to you. Okay, but if you see in UDP, so it's a request response, right? So whatever you are sending, it will be transferred directly to the receiver. It will not. There is no handshakes. There is no nothing. SYNAC packets will be shared before that. Okay, so that's why there's a handshake in between TCP and UDP. So that's why the TCP was a bit slower comparing to the UDP. And if you see in UDP, sorry, if you see in TCP, there is one of the features has a TCP like a error control. Okay, there's an error control, and there's a segment numbering system. Okay, every data we discussed about all the segments, right? In transport layer, every data will be segmented, right? Source IP, destination IP will be added, source MAC and destination MAC will be added. We'll discuss that in previous video. So every data has a segment number, sequence number. Yes, sequence equal to 1, sequence equal to 2, sequence equal to 3, and sequence equal to 1000. Okay, so sometime if the sequence number 3 was missed, so in this is a sender. So let's come up with the receiver. In the receiver side, so receiver received sequence number 1 packet, received sequence number 2 packet, and receiver received sequence number fourth packet instead of third packet. Okay, third packet will be missed. Okay, so now what TCP will do, it will arrange all the packets. Okay, 1 2 3 4 5 6 2000. Okay, so then it will check what are the packets are missed. So it will identify there is a packet number 3 was missed. Okay, so now what TCP will do, TCP will ask the sender to resend this third packet. Okay, resend this third packet because there's a data loss. Okay, the third packet will be lost, so the TCP will ask the sender to give a third packet one more time. Okay, now sender will transform the third packet to the receiver, so that we are saying TCP has a better mechanism comparing to UDP. So whatever we are sending from TCP, everything will be arrived to your receiver properly. Okay, without any interference. Okay, so now discuss about the UDP. Okay, UDP will be much faster than TCP. There is no handshakes and no error control mechanism. No error controls. Okay, no error controls. Okay, so we will say this is a error control. Okay, so there is an error. There is a packet will be missed. So we are saying that's a error control mechanism was implemented in TCP, and there in UDP there is no error control mechanism. So if the packet was missed, so the packet will not be the UDP will not ask that packet send one more time to the sender. Okay, so UDP will not ask the packet to send one more time. Okay, if the packet was missed, it will be the UDP will not worry. It will just transfer what you are saying. Okay, it will just transfer other data what you are saying. It will not care about the packet. So we will not give any assurance to your packet if you are sending to UDP. So that's why in video streaming applications, some of the packets will be missed, and you can't able to hear the voice, or you can't able to see the video in between if there is a communication issue. Okay. So next one, also the TCP has a flow control mechanism. So there is a flow control mechanism will be implemented in TCP. So it will send the data. It will see what's the limit of the limits to transfer the data. Okay, it will limits the data to transfer it to the receiver. Okay, because to ensure the reliable delivery, all the data will be received to the receiver. Okay, no data will be lost. Okay, there's a flow control mechanisms are there. Okay, flow control mechanism is basically a data transferring mechanism. uh, so if you are sending all the data in a fast manner, in a very fast manner, then many data will be missed. Okay, so TCP will set a flow control mechanism for that, and it will send the data one by one. Okay, so how it will check the capability, how much data we can send, and it will sends that data. Okay, so that's all about this video. It's a difference between the TCP and the UDP. Okay. Hope you enjoyed the video. So no worry, some parts will be theory here because you need to understand what's the networking and what's the concept of the networking. We already said in the previous sessions. Yep. Thanks for watching the video. We will see you in the next video. Bye bye. Hey guys, welcome to this video. In the previous video, we have discussed about the TCP and UDP, how the protocol will be working, and why it was connectionless and connection oriented. So we will discuss one more thing that will be added in the transport layer. So that was a port number. Many of them know what's a port number. So let's start the discussion about the port number. Okay. So in computers, there are many services we are running. You are using the Google Chrome for reaching out to Google or any other web servers you need, or you need to transfer some files to one place to another. So you are using FTP for the file transfer protocol, and there is a DNS was running, so domain name system. There is lot of ports and protocols will be running in your machine. Maybe there is a SQL service, so SQL will use some other ports, right? So why we need this port for in OSA layer in transport? Why this port number is added in the transport layer? Let's discuss that. Okay. So in the computer, so let's take this computer as an example. So in this computer, there is a application called Chrome was running. Okay, and there is one more application was running like Zoom, and again there is another application like MySQL. This service was running. Okay, so this computer was sending some data to multiple servers. This server is for Chrome, and another server is for Zoom, and another server is for MySQL. So this is for the MySQL, and it's for Zoom, and it's for Google. So it was using different servers and different application to reach out to that servers, right? So if there is no port numbers where specified, your computers don't know which data will be sent to which application. Maybe if there is no port number, so the Zoom will send the data to this Chrome, or else the MySQL will send the data to the Zoom. So the packets will be get collide. It will be confused before arriving into the machine. So we are using the specific port numbers for that in the HTTPS. When we know when we searching in the Google, there is a one of the protocols get added like it's a HTTP. So we have a separate port number for HTTP. Yes, it's a 443 that will be added. Sorry, that will be added in our in the transport layer. Okay, so the TCP or UDP that will be added, and the specific port number that will be added in our data. Okay, in the transport layer, so the data knows which servers I need to reach and which applications I need to reach out to the results. Okay, so for example, the Chrome was running in 443. So this port number the Chrome was using, and it was requesting something to Google by using the port number 443. So now the Google servers know which application, which port numbers I need to send. So it will directly send the data to the chrome.exe, right? And there is Zoom application, maybe the Zoom was running in a 3050 port. So it will send this similar result video streaming to the particular Zoom application, and the MySQL was running as a 3089 for an example. So the MySQL know which service I need to send. Okay, by using the port it will track which application I need to send the data. So, okay, we are using port number for that. If there is a no port number, so we are unable to track the data. So where it will be arrived, it will be arrived in Zoom, or it will be arrived in MySQL application. So we have a several protocol for that. Okay, if we are using the FTP, if you want to transfer file from one place to another, so we are using the FTP protocol and SSH for configurations. So we can briefly see what are the common ports and protocols in the upcoming videos. But now we can understand what's a port. Okay, because the ports numbers will be added in the transport layer, right? So this is the explanation for the port, why the port numbers will be added in our data packets. Okay, so I think you enjoyed the video, and I hope you have a clear understanding about the port numbers. So let's end this video, and we will continue in the next video. We will continue in the next layer called a network layer. Bye bye. Welcome to another video. In this video, we will discuss about the network layer. So this is the top. If you counting from the bottom of the layer, it will be in the third layer. So if you counting the top to bottom, it will be in the fifth layer, right? So this is one of the important layer. The source IP and destination IP will be added in this layer. That's called as network layer. So let's see how the network layer will be, the working principle of the network layer. So the main working principle is like there are two things. One is the source IP, and the destination IP will be added in each of your packets which was sending, right? So in the transport layer, we have a lot of segments we already seen. There's a lot of packets we have. So we need to route this packet. We need to send this packet to the target server. So here is our machine, and we need to send it to the Google server. So from here, and we need to take the result from Google server to our machine. So we need to add two things in that. So one is a source IP, and another one is a destination IP. So source IP is your IP, and because you are when you are querying something to your friend, so you are giving the source IP as well as the destination IP, right? So you are giving both of the address. So because if the yeah, let's break that. Let's continue here. You are giving two address, your address and your friend address, right? So the similar way we are giving our address and the destination address to all the packets which we are sending. Okay, so our IP is like it's like 192 or something. Okay, this is our IP, and the destination IP that was a Google IP. So just we can get the Google IP ping google.com. So 142.250, 193, 142, it's a Google IP 142.250, right? So this is a Google IP. We need to add both the things in every packets, okay? So this is the working principle of network layer, the most important thing. We will, there is a lot of things will be in the network layer, but in cyber security, so what we need, so these are the few concepts we need, important concepts we need. So we are discussing that concepts in this course. It's not a professional networking course to explain each and everything in the protocols and in the background process of every layer. So but we need it's enough for us. We need only a few things from the OSI model. So that's why we are covering we are covering this much. Okay, so this both things will be added in the every packets. Okay, so next thing, there is a data link layer. Okay, so let's break this, and before that we will discuss a few more things in the IP addressing in the network layer. Okay, so I already said there is a source IP and the destination IP will be added here, and so there is a two IP address. One is a private IP and another one is a public IP. We have two IPs. One is a private and another one is a public IP. So the private IP is like it was provided by your router. So let's explain this mechanism. So here you have your own home router. So inside the home router, there is a lot of machine that was connected with your router, the mobile phone, PC, computers, and TV. Okay, TV, tablets, a lot of devices are connected. So this modem or router will give the private IP to it's like 192.168.18.1. Okay, so if you take the command prompt and if you give the IP config slash all, so here you can see this is a default gateway of the uh, network. This is a default gateway of the network. So my router IP will be like 192.168.18.1, right? So every packets from my machine, so every packets in my each of the machine, this machine, it will first reaches to the default gateway. This is the gateway, right? So this is the gateway between uh, our computer and our Google server, right? Or any other servers, right? So this is the gateway. So we will this is the IP address of my router, and the router will assign IP address, okay, to every machine by using some DHCP protocol, uh, 18.3, 18.4, or 18.5. There is a lot of machines will be connected inside your network. So every the router will assign private IPs to every device inside the network by using the DHCP protocol. We will discuss this protocol later. Okay, so if you need to communicate, if you need to send hi to this computer, to this mobile phone, you can use a private IP. Okay, so you can use a private IP for a communication. Okay, so if you need to send anything inside your boundary, inside your network, you can use your own private IP, which will be given by the router or a modem. Okay, router or a modem, you can use this you use this private IP to communicate inside your network. Okay, so but if you need to communicate outside of the network, this private IP will not work, if because you need to going to you are going your packet will be going to this, and then it will be routed to your Google servers, right? So this private IP will not work here. Okay, so we have a that's why we have a public IP. Okay, so I'm not going to show my IP in a public. I will show my uh, yeah, no problem. I'll show my IP. If I going to Google and I'm searching what's my IP, so you can see here, this is my public IP. This was provided by the service provider. Okay, so the public IP was provided by the service provider. So who is a service provider? So like Airtel or BSNL, so even network providers, okay, or Vodafone. So the service provider will give you the public IP. That's why they are you are paying some amount every month to your service provider. Okay, so for this IP, okay, and if you need to communicate outside in your network, so let's go to the public IP. If you want to communicate, let's say here is your modem, and there's few devices inside your network, and this device needs to communicate to the Google server, which was not in your network. It's outside of the network. What's the inside of the So whatever machines connected under the router or a modem, it's inside of the network, and other machines are outside of the network. Okay, so you can't able to communicate by using the private IP. The private IP you can use in a uh, inside of the network. So if you want to communicate outside, so you need a public IP. So this computer have a private IP of 18.2. Let's take an example. This needs to communicate with the 142.250 the Google server. So the packets will be first sent to this. Okay, the packets will be first sent to this, and the router convert that private IP into the public IP, and it will reach it to the Google server. Okay, from here to here your uh, packet will be like, it's like a 198.18.2, and from modem it will convert your uh, packet with the public IP. Okay, so it will add your public IP 58 dot 15 dot 85 something. Okay, so it will convert your private IP into the public IP by using one of the service like NAT. Okay, network address transaction. So the network address transaction is like, it the main purpose of network address transaction is it will convert your private IP into the public IP. Okay, so the main purpose, it will change your private IP into the public IP, so you can easily communicate with the Google server. Okay, so this is the overall brief of the private IP and the public IP. So which will be added on the network layer, right? So in the private IP, let's go for one more review. In the private IP, you can use only the private IP for inside of the network communication. But if you want to communicate outside of the network, you need a public IP. So the public IP has been provided by the service provider like Airtel or BSNL or Vodafone. So they will give a separate IP to you, and by using that IP you can communicate outside of the network. Okay, so this is the overall explanation of the network layer. Okay, let's hop off this video and continue in the next video. See you guys.